Hello, welcome back. And we are going to analyze this circuit, which is called as Class A amplifier with transformer coupled circuit. So we are using this transformer into the circuit to couple the input side of the signal to the output side of the signal. The drawback of this circuit is, however, you have a bulky transformer that is to be used in the circuit. Now, let us step by step analyze how this circuit works. So we are using NPN BJT. As the direction of the arrow shows, the current will flow from collector to emitter. Now, we want to use this transistor as an amplifier, as I said, a Class A amplifier with transformer coupled circuit. So we need to bias this transistor in an active mode of operation. Now, what is an active mode of operation? An active mode of operation, we say that the transistor has the IV characteristics, where I is the output current, IC, and V is the output voltage across the collector to emitter. And we bias the transistor in a linear mode of operation. It means for a given value of base-emitter voltage, that is VBE1, or rather I would write here, for a given value of the base current, you have this kind of rise in the collector current, and then the collector current saturates, and the region right to this line is called as linear mode or active mode of the transistor, and the region left to this, indicated by the shaded lines, is called as saturation region of the transistor. So we want to make sure that the transistor operates in the linear region or active region, and it provides the constant collector current. And therefore, we make sure that we provide the biasing in such a way that the base emitter junction of the transistor, that is base to emitter junction of the transistor, is forward biased, and base to collector junction of the transistor is reverse biased. Now, how to ensure that? So here we see that there is a diode between base and emitter, and there is this diode between base and the collector, because there is basically a junction, PN junction here and PN junction here. So what we see and what we do, we make sure that the voltage drop across the base emitter, which is VBE, and here the voltage drop across base to collector is VBC. So VBE is positive and the VBC is negative. So in other words, we have to make sure that your voltage at the collector, which is at this pin, is at least greater than or equal to the base emitter voltage of the transistor. So you see here, let me write, there is going to be VBE, and here it is going to be VBC. VBE is the difference between base voltage and the voltage at the emitter. VBC is the voltage at the base and the voltage at the collector. That is the difference between the two. Okay, so we see here from this equation we can write VC is greater than or equal to VB minus VE. This condition will ensure you have a constant collector current and the transistor will be operating in the linear mode of operation. Now we need to provide this VB here. So what you do, you use the resistor RB to provide the biasing to the transistor. This is the voltage supply VCC from which you draw the current I, and that current I flows through the resistor RB and provides the voltage at the base terminal, and that voltage must be greater than 0.65 to 0.7 volt for the silicon transistor. So VBE should be greater than VBE, that is greater than or equal to 0.65 to 0.75 volt for the silicon BJT. Now that condition is met, and again, as I said, the junction diode in the reverse bias case should be reverse bias, and the junction diode in the input side forward condition should be forward bias. Now there is a voltage drop across collector pin and the emitter pin, that is called as VCE, and that is the VCE. Okay, and this condition is VCE minimum. So your VCE should be greater than VCE minimum. Okay. Now, what is the role of this transformer? So you see that it has a primary winding and it has a secondary winding. So there is a turns ratio called as N1 is to N2, where N1 is the primary winding, number of windings in the primary side, and N2 is the number of windings in the secondary side. And this is the load resistance across which the output is developed, which is called as voltage across the secondary winding V2, and here is the voltage V1, which is the voltage across the primary winding. Now you choose the turns ratio in such a way that you can have 1:1 or 1:2 or 1:n times of winding, and depending on that your output V2 will be proportional to V1. V2 would be greater than or equal to 1. And then V2 is nothing but your voltage that is developed across the load. Now, the capacitor role is to couple the AC input signal to the base pin of the transistor and blocking the DC component into the present into the input signal. So that is how this circuit will work as a class A amplifier with transformer coupled circuit.